Hello everyone, welcome back to another interesting video in the Langchain projects playlist. This video we are going to see about an interesting project, like I said, which is going to be a real-time AI research agent for your own. Okay, so it says right, RoboWiz, your 24/7 AI research apprentice. That is what we are going to build. So you might think, Vasant, again we are going to have some PDF and then we are going to load it. That is what we are going to do, right? What is going to be different here? Yeah guys, trust me, this is very different because this is a real-time AI research agent. Okay, whenever you provide a query, it will try to find the best resource from the internet and it will try to answer your query. So that is what will happen. For example, this was also a query which I provided at runtime, where I asked what is direct preference optimization, where it responded bullseye. We can say simply it is a bullseye response. Okay, direct preference optimization is a method proposed by, it is showing RAF2 3D. I don't know what it is actually, to be very fair, and probably it might be some URL or something like that. Let's not go by in there. Okay, RAF2 3D for aligning language models to human preferences without using reinforcement learning from human feedback. DPO replaces the combination of reward learning plus regularized RL in RLHF by plugging the policy, which is the language model, directly into the reward objective and only optimizing the latter, which is actually the crux of the direct preference optimization concept, guys. To be very fair, this is more than enough to tell about what is direct preference optimization, and it has finally said that in summary, DPO is a method that simplifies the training process of large language models by directly optimizing their preference towards human feedback instead of using a combination of reward learning and regularized RL. This is the exact response which I wanted from the model, and it has provided exactly. Isn't that amazing, guys? Because this runs in your CPU actually, which is something which I very much focus in our channel, where I don't want to mostly go on to OpenAI API calls. No, in this video it is no different. We are not going to go for OpenAI API calls, and we are not going to use any GPU as usual. It is completely open sourced and it is in CPU. So if this interests you, I request you all to stay till the end, and yeah, let's all build our own research assistant so that our learning process, or else even if you want to write some content for some person, it may be very simple with this bot in hand. Okay, so let me say how to build this bot. But before going on to the building process or workflow discussion, there is an important thing which we are gonna see in this video, where there are some prerequisites. Okay, so let me show you what are the prerequisites and how to complete the prerequisite rather. Yeah, first step is obviously we need Llama model R guy. Okay, our trusty Llama model, where we have used it for any and every Langchain project which we have built, and this video is no different. Still we are gonna use Llama model. Okay, so we are using Llama here, and you can download your version of Llama which you prefer. So I have downloaded Q41. I've always said you can download it as per your preference, and some persons ask me, Vasan, how to choose my model? So here is your answer, guys. So this is the model name obviously which is provided there, and see the max RAM and use case. That is what is very important. Okay, the quant method, which is also important, but when you have computation issues, this main thing you need to see is max RAM. See, my system can handle up to 7 to 8 gigs, so I thought, okay, Q41 is good because it has quicker inference than Q5 models, though Q5 is highly accurate than Q41. It has slower inference, which I don't want. Okay, so I thought, okay, let me go for Q41. But still, if you have high CPU RAM like and very powerful, you don't care about how slow it is, but I need accurate result, you can even go for Q80 bin. Okay, but it will take at least 10 gigs of RAM. So based on this you can choose, and if you are guys who have only 8 gigs of RAM, still you guys have got you, I mean the bloke guy has got you, where you can use Q2K.bin, which is only 5.37 gigs. Okay, so first step is download this and keep it in your local. So once this step is done, which is your first step, next step is to create an account in Serper. Okay, Serper is the world's fastest and cheapest Google search API. Okay, so you can get your Google search results within 1 or 2 seconds. Okay, so this will be some kind of response. Let me come to this response later. Okay, so this is a response. I'll show it in a different way, but you can get this kind of response for any given query. So that is what Serper provides you, and they provide you integrations with all of these. So here you can see, right, you can use it in Langchain, which we are using. There are some other companies also using, and here if you see, these are all some packages. And you might wonder, Vasant, you said we are going to use everything free. Yes guys, we are going to use everything free because Serper has provided 2500 free queries. Yes, it is 2500 free queries. So let me sign in. Yes, I've already signed in. So you can see, right, I have used 53 requests till now, and I have 2447 requests still left. And yeah, if you are completed with your request, just go for another account, right? Like if email accounts are free, you can create 10,000 email account, then multiply it with 2500. How many API requests you'll have? So yeah, still I'll consider this is a free source. So yeah, this is pretty good. So first step is to download the Llama model. The second step is create an account in Serper, click this API key and make ready your API key. Obviously I can't show this now, so click this API key and you'll have your API key ready. Okay, so that is the second step. Once that is done, the next step is to go for this Weaviate. Okay, let me show what is Weaviate. So Weaviate, actually, if you see, it is an open source cloud vector database actually. Okay, so it will help you to store vector embeddings like Phase itself, but the key difference is this is a cloud vector database. Okay, so that is a very good thing. And also if you see the vector search it provides, like the result of the search, it will be very accurate, guys. Trust me, this is one of the best vector database which you will find online. There are some other alternates also, like Quadrant or else Phase, like we have used already, Quadrant, Phase, and there is another one called Pinecone, which is for commercial purposes. Okay, because it will retrieve faster than all of these options which I have said, but the result will be slightly lesser. Okay, but it can store a lot of embeddings, like audio embeddings, video embeddings, everything. So yeah, we are just going to focus on Weaviate now. And if you see, they have provided integrations with lot of frameworks. So transformer support is there, DeepSet, which is Haystack, which we have used already. For that also it is providing support, Gina or else OpenAI and Argai, Langchain. For everything support is there. So we'll see how to integrate that, but let me go with creating an account first. And because we know now, right, Weaviate is good, so let it be good. Let us go with the prerequisite completion path, right? We know, right, it can be used for our project, so that much introduction is more than sufficient, I guess. Vasan51430@gmail.com, my password, I'm just providing it. So here you can see, right, my password is provided. Here if you see, there will be this option called create cluster. Actually, this is a dummy cluster which I used for testing purposes. This is the cluster which I am using right now for this specific video which you are seeing right now. Okay, so here if you see, the API key should be provided and the URL for this cluster is this one. Okay, so these two are very much important. So for this, what you need to do is you need to create your own cluster first. So click this create cluster, and then here you can see, right, this is completely free, and the only disadvantage here is the lifetime. Okay, so here it is 14 days lifetime. Here and all, if you see, it will be infinite lifetime, everything, like, it will be very infinite lifetime. But still, even if you see, the payment amount is also very less, but we are gonna use free version, right? So yep, we are going for lifetime free one. So you can just provide some value here, some cluster name as per your wish. Okay, so click create. Okay, so once you click create, it will try to create it. And guys, you can create how many ever clusters you want, doesn't matter, it will just create it. And once that is done, what you need to do is click connect here. You'll have your URL. Okay, so if you are feeling it tough here, you can also click details here. because obviously we need to go into details. First is click this cluster URL copy button and have your URL ready. So, and after that you need to also get the API key. Okay, these two are needed. So once you are done with these, obviously like I said, download your Llama models, get your Serper API key, get your Weaviate URL, client URL. This will be our client URL. Okay, and then you'll also have your Weaviate API key. If these are done, you are done with your prerequisite, guys, and you are set to go. So I hope you all followed this video and done live along with me. Okay, because I have obviously gone slow only so that you can follow this and do in real time with me. So yep, don't worry guys, all the links are provided in the description, so you can just click the links and then just create your accounts and be ready with your API key before moving on to the project. Okay, now let's go on with the project. So let me fire up the VS Code. Okay, so yeah, here is our guy RoboWiz. So this is the workflow of RoboWiz, guys. So here if you see, when you provide your user query, right, don't worry about the coding side. Obviously we are going to see in detail. At that time we'll go on with this in detail, but I'm just letting you know the overall workflow. All right, so when you provide the user query, what will happen is it will try to find the relevant URLs by using Serper API, which will obviously hit a request via to the Serper API, and then from there we'll take the top URLs. Okay, now you'll have a list of URLs, and then you'll provide that into unstructured URL loader of Langchain. Okay, what it will do, let me say that also in the later stage. Okay, so once you pass that, you'll have the URL contents documents. So once you get the documents, obviously the next step is, as you all guessed right, it is chunking, where we'll chunk the data into 1 to n chunks, and then we'll be computing embeddings for those. So once that is done, instead of storing it in phase, we'll be storing it in Weaviate vector store. Okay, there is a huge difference, though in code it is very light. There's a huge difference between using phase and Weaviate. So let me tell about that also later. Okay, so once you provide store it in Weaviate, obviously your query embeddings also will be computed, where we'll provide will perform a semantic search to get the top result, and that will be provided to the RetrievalQAChain. Finally your answer is displayed. So this is the overall workflow of this project, guys. I hope you all understood. So let me go on with the coding right now. Okay, so before going on to coding, I would like to let you know about the installation dependencies. Okay, so obviously you need Langchain. This is not something new. C transformers, this is also we have done obviously, but unlike others we have used Weaviate, right? So instead of installing phase, you need to install Weaviate. Okay, pip install Weaviate and you'll be ready with that. So for unstructured URL loader also you need to install pip install unstructured URL loader. Okay, so if you hit it in Stack Overflow, you will get the top result, and you can install unstructured URL loader. Along with that, also load the PDF version of unstructured URL loader. Okay, so if these are done, I hope everything would be enough for you all for installation dependencies. But still, if you face any error at all, let me know, guys. I'll try to solve your errors through the comment section, or else even you can join the Telegram group. The link is in description, and then I'll help you out there also. Okay, now let's go on with the researcher file. Okay, so we'll go on with the top down approach. So we'll go on from UI to the backend. Okay, so here if you see, we have Streamlit chat. From there we are importing message so that we can display the message. Okay, the researcher Weaviate file, because we are using Weaviate as vector database, I just kept it as the name to be self-explanatory as researcher Weaviate. From there we are using researcher class. Okay, and also we are having .env. Okay, this is a package which is used to interact with .env file. Like I said, guys, this API key is highly sensitive. That's why I even didn't show you all. Store that in .env file. Okay, so that is the best practice. So store that in .env file. To find that file, you have find.env function, and to load that file, you have load.env function. What it will do is it will try to set your environment variables. Okay, now since your environment variable is set, we are ready and good to go. So next is obviously starting with creation of our layout. which I'm setting to wide, so that we saw, right, our guy RoboWiz was on the left and the chat box was on the right, but still it took huge space, right? So to cover the entire space, we set the layout to be wide. Okay, so after that we have used session state dot clicked is equal to true, so that the session state is maintained till the end. So there was this one issue, guys, which I ran into. I hope you all know by now, because we have used this in previous videos as well. This buttons which you use in Streamlit doesn't retain your state. Okay, so to avoid the page being reloaded for every time you click the button, I've used this session state dot clicked equal to true, so that I can do condition checks based on this. Okay, so that is there. Other than that, it doesn't serve any purpose. Okay, it is not like our session state which we use for displaying conversation. It's not like that. Okay, so we have create researcher, which will create the researcher, obviously, from by using this researcher class. Okay, so yep, finally we have display conversation function also, which will display the conversations. Now let's go on with the UI. Obviously I'm checking if the session state dot clicked is true. It is funny because we know that it is true. Okay, so here if you see, we are displaying that RoboWiz, your 24/7 AI research apprentice is there, and then subheader is an AI apprentice who can serve you 24/7, because like I said, you saw the result, guys. It was from internet. Okay, so from where it got that, don't worry, I'll show you a response file where you can see in the left, right, response.json. From there I'll show you all. Okay, so that response.json file will make you sense why this agent is pretty good. Okay, so yep, here if you see, we have our 24/7 research assistant, which will answer based on real-time context. Okay, and then we are having two session states. One is for user, another one for apprentice, which is our researcher. So for user, we have the first message being hey RoboWiz, and apprentice replying that hello, how can I help you rather. So here if you see, the gap, or else the space allocated for this research guy, which is our RoboWiz, he's smart. Yes, our bot is also smart, this guy is also smart. And guys, this image was also generated by using AI. So here if you see, the space allocated for this is pretty less and this is more, right? For that, what we done was we split the whole layout or the whole page into 3 columns, and one column is allocated to the image and the rest of the 2 columns is allocated for the box. Okay, so that is how it happens with st.columns. Okay, you can separate it to number of columns and you can provide the number of columns to how many ever variables you have, how many ever containers you have rather, because these columns will act as a container. Okay, so in the column 1 container I have the image being displayed, and in the column 2 container I'm having an expander which will have the multiple elements in it when we expand, and when you close it, all the elements will be collapsed and it will be stored inside the expander itself, in which we get the text input from the user, which is we are saying it is the research query, and once the user clicks the send button, it will go on with the research function in the research apprentice we created from here, which we cached obviously, so that we need not create this researcher again and again. So let me go on with the research function now. So here is our researcher. Okay, so when you go on to this research function, the first step would be to search the articles, right? We even saw in the workflow, like I said, we need to hit an API request to the Serper API, right? So for this you need URL, okay, which is google.serper.dev/search. In this URL only you can hit the API request, and the data which you need to extract based on is your query. Okay, and it expects in JSON, so have it as JSON string. Okay, so that is what will happen with JSON.dumps, and with the key being Q, we are providing the query. Okay, and it also requires API headers where it will contain the API key and the content type. We have initialized the API key in the init function itself. Okay, So in the init function we have the Serper API key and other imports, other initializations when we are going to specific functions. Let me tell you about that. Okay, now coming on to this get URLs. Sorry, not get URLs, search articles. Yeah, sorry for the confusion, guys. So here we are providing the Serper API key. So once you provide the Serper API key, you are hitting an API request, which is post request, where you can provide a given a value, and based on that value it will return some value. That is how post request works. And in that post request we are providing the URL in which the request should be fired up, and then the API headers along with the data payload. Okay, so once you provide these, the response will be provided as JSON. So here is the JSON response which I'm going to show you now. Okay, so for better view I'm just using this JSON viewer. So here the query was direct preference optimization, right? What is direct preference optimization, which was provided there, where it shows that okay, engine is Google and the type is search. We know that. And here if you see, it will return the following keys, guys: related searches, search parameters, answer box, and organic. Okay, in answer box there will be 5 keys inside that also, which will be date, title, link, snippet, highlighted, and snippet. Okay, so snippet is something like the most relevant context of the whole document. Obviously this itself is using some kind of whittling down and AI, but this is not the exact response we aimed, right? Though it is good, it is not something which we aimed. So here it is saying with direct preference optimization, a language model can be aligned with human preferences without using reinforcement learning, which will simplify the learning process. But this is not the exact thing which I am expecting here. And here also if you see, the snippet is not something which is good. Okay, so what happens here is, here it will take the links alone. That is how I have written the code. We only require these links. We don't care about the title, snippet, highlighted, snippet, date, nothing. We only care about the links. Okay, so which are the links we need to consider? That is the next question. Okay, so this is how the API response would be from Serper. Now let me come on with your getting the URLs, top URLs. Okay, there are some methods for that. So we are going for the simplest method available. See, here if you see in the workflow, let me open the workflow. Here you have this workflow. In this I've said fetch the top URLs, right? We don't have the leisure of calling an API request to OpenAI. So why am I saying that? See, OpenAI has shown that the ChatGPT or GPT-4 has the capabilities to generate response as much as humanly as possible. So if that is saying that an URL is good, then the URL should be good. Okay, so in that assumption you can also hit an API call to ChatGPT or GPT-4, and then you can get the top URLs. That is one way possibility. But the way which we are doing is, we are taking the answer box, which is Serper considering being the answer for the given query, and organic is something like, you know, the chain of links which is possible for being the answer for the given query. So what we're doing is, we'll be considering some specific amount of URLs which I'm going to show now. Okay, so here if you see, we have the articles now. Like I said, the next is to get the URLs. Here if you see, we are going to get the links from the answer box. Okay, so if it is available, we'll get the links, and along with that, in organic, like I said, in the chain link, right, we'll take top 3 URLs. Okay, we only need maximum of 3, so that's why I've checked a condition, right, for I in range of 0 of min of 3 comma len of articles of organic. So why I've kept that? See, first is to limit the response, limit the context rather, because with the increase in context it will take significant time, rather it will not might be very noticeable, but even the search time will still take some time. Okay, so but the context for Llama, it's not going to increase because we are doing RAG, right, retrieval augmented generation. The context size won't increase at all with the increase in number of documents which we are providing here, but the search time of the relevant documents would increase. Okay, so I'm just taking the top 3 documents, how much ever it is there, doesn't matter. But if it is less than 3, I need to take that much alone. So let's say I have only 2 links available for the given query, then I'll take 2 only. For that only, I'm just having this check called min of 3 comma len of articles of organic. Okay, so from there we are appending the URLs again. So finally, on a best case scenario, we'll have 4 links. Okay, so now that is done. So here if you see, we have fetched the top URLs and we have the set of URLs now. Next is to provide it to unstructured URL loader. So let me show you that. So you have the URLs which you are providing to get content from URLs, which takes URLs as its parameter, and we are providing it to unstructured URL loader itself. So let me show you about unstructured URL loader. So it is, if you see, it uses an unstructured partition function. It will detect the MIME type, and based on that it will try to load the content in 2 modes, which is single mode, where all the documents which it has retrieved, it will try to retrieve in a single object, okay, which is what we need. And then there is another mode called elements mode. It will try to return it in title and narrative text. Okay, so this is a detailed explanation for unstructured loader. So in unstructured loader, if you see, it will take some parameters like mode, which is single, which we are not disturbing, and also there is continue on failure, because it is not sure that we will always extract all the URLs, right? So to not stop the execution, we are setting it to continue on failure is equal to true, which is the default one. And then also here if you see, we are setting show progress bar is equal to false, because it is not needed right now. But if you are having number of URLs, I suggest you to make it to true. Okay, so that is about unstructured URL loader. So once you create your loader, just call the dot load function, which will create your document, okay, which will have the contents of this links, okay, in a single document object. So now you have the document being ready. Okay, URL contents are now ready. Next step is to chunk it. Okay, now the URL contents are ready. Now for the step is to go for researching the given query. So for a given query, we are researching based on the content. So first we are splitting the documents by using the recursive character text splitter, which we initialized here. Okay, so here it is there, right? Recursive character text splitter, where it takes /n as its separator, and chunking process is done, where the chunk size is 500 and the chunking overlapping is 200. If you need some bigger response, I'd suggest to increase the chunk size and chunk overlapping. Okay, so once you chunk it, the next step is to create the Weaviate vector database, for which you need to install this package called Weaviate-client. Like I said, you need to install Weaviate client. Okay, so once you install Weaviate client, you should be more good to go for this execution. Okay, so in this, it takes the following inputs. Okay, it takes documents, embeddings, and we need to provide the client also. Okay, so how to install create this client, because if you see, we are calling self.client, which is a client object, and also we are calling self.embeddings, which is Hugging Face embeddings. So let me show you about that in the initialization function. So first, if you see, we are getting the Weaviate API key environment variable, and based on that, we are providing an API key to the Weaviate client via this auth API key, which is used to authenticate your Weaviate client. Okay, so that is obviously the purpose of API keys, right? So in that, we are providing the Weaviate API key, and we are making a client for the given cluster URL. I said, right, we buried with your cluster URL API key and all. So that cluster URL you need to provide here. Along with that, you also need to provide your auth config, which is obviously the auth API key. So here for embeddings, we have used GT large as usual, based on the MTB leaderboard being in top 3 and also have given good performance till now. So we are not going to change anything from there, but still, if you want, you can also try to use some different models based on some reason, obviously. And then we have the device set to CPU, so that executions will happen only in CPU. Okay, so based on this, a Weaviate vector database will be obviously it is already created. That is why the sandbox was created, right? In first, in that we'll be having these indexes. Okay, so these indexes are now initialized inside this vector store. Okay, finally we are having this research answerer, which will take the following. Okay, and guys, one thing you need to notice, we have this db being in self, so that we can call this in any other functions. Okay, that is an important thing to note. So once you are done with creating your vector database, obviously you need to go for your retrieval QA chain as usual, where in chain type we are providing the LLM being C transformer Llama, so Llama, and the model type being Llama. Okay, and max new tokens is 1024 and temperature is 0.7. Let me go to the config. I hope it is 0.7. Yes, 0.7 means it will be slightly creative, not more extractive. Okay, so close to 0 it will be very strict in nature, and close to 1 it will be very creative in nature. Okay, so that is the based on the proximity, it will have its own characteristic. If you want to balance it, keep it in 0.5. okay, so we are keeping the chain type as stuff, and so that it will stuff all the documents in a single content. Okay, and then we have our retriever being the vector database itself, where we are taking the top 2 results. Okay, so search keyword arguments k is given as 2, which will take the top 2 documents, and we are setting the verbose equal to true, so that we'll know what is happening behind. Okay, so usually we don't know what is going on behind. So to know something about what is going on behind, we have set the verbose equal to true, and we are providing the prompt template. Okay, so prompt template is created here. Here you can see, right, you are a great researcher with the information provided, try to end up understanding that. So this is provided, guys. Okay, now you have your researcher ready. The next step is obviously to get the answer, right? So once you provide the call to here, you will be able to get the answer. So that is what we are doing here, right? So in research, if you provide the query, you will get your answer. That is what is happening. So finally you have the output ready, so which means we are good to go with the chat display side. So for that, obviously we need the session states, right, so that we can display based on the session states. So in user session state, we are appending the user query, and in assistant apprentice session state, we are inserting the output of RoboWiz. Okay, so if the apprentice session state is there, so the display conversation is called, where we'll go on through the history of conversations, and we'll display the user with user equal to true parameter being set, so that the conversation will be on right, and there will be this smiley image near the conversation of user, and it is not set here in apprentice conversation, so that it will be on the left side, and also it won't have the smiley image, rather it will have a kind of robot image. Okay, so finally once you are done with all of these, you will have this application, guys. So yeah, I hope you all like this application, guys, because from my view, I thought YT Buddy would have been the biggest project of our channel, but now this is the biggest project of our channel. So yeah, guys, if you all like this kind of videos, please hit the like button. I hope you all enjoyed this video actually. So to me, being enjoyed, I obviously will be overjoyed with your likes. So hit the like button. So once you have hit the like button, if you don't like, also hit the dislike button, but please provide your comments in the description, so that I can improve the content in the future. And also need not be some feedbacks. You can also provide some video suggestions or video requests, or any other discomfort you are feeling while execution of this project in the comment section, and also share it with your friends and communities of this project. And finally, I would like to ask you all to subscribe to the channel, guys. Not just subscribe, please hit the notification button, because people are saying that the notification is not coming when you are premiering the videos. So to get live updates of premieres or also the community posts, so please hit the notification button also, so that you can be updated with our channel contents. So in the next video, it is going to be more interesting, because we are gonna create an AI girlfriend actually. Still we are not going to use OpenAI as usual. It is going to be all open source component, but still we are going to build an AI girlfriend, and I hope you will all like it actually. So I'll see you all in the next video guys. Until then, cheers.